Chalo, let us solve next problem. I think we have solved integral x tan x square x dx last time. Next problem is integral log x square E55. Integral log x square dx. Is it? Solve this. Okay. Okay, this is easy. Again, integration by parts. Assume second function to be 1. And then you are required to find out integral of log x, which we have done it last time. And hence the answer is x log square x minus 2x log x plus 2x plus c. E56. Integral x cube e raised to 3x d. Sure, fatafat get me the answer. We will solve several problems and learn many techniques through problem solving. Okay, so now it is a repeated application of integration by parts, and the answer is x cube e raised to 3x upon 3 minus x square e raised to 3x upon 3 plus 2 by 9 x e raised to 3x minus 2 by 27 e raised to 3x plus c. So now can you generalize this and write down the formula for integral e raised to ax f of x dx is equal. Write down generalized formula for this. Now every time you do the integration by parts, it is u into v, and as I said, this f of x is u and e raised to ax is v. So u into integral of v, first term, that is f of x e raised to ax upon a. Integral of e raised to ax is e raised to ax upon a. That is the first term, minus integral of v into derivative of u dx. Now first term will continue as it is, f of x e raised to ax upon a minus. Now apply integration by parts once again. Maybe you take out a common and then it is e raised to ax f dash of x. Again, e raised to ax upon a into f dash of x. That is u into integral of v minus integral of e raised to x upon a into f double dash of x dx. If you resolve this bracket, you will get f of x e raised to x upon a minus f dash of x e raised to x upon a square. And then you are left with 1 plus 1 upon a square integral e raised to x f double dash of x dx. Now if you apply integration by parts once again, you know the pattern now, and therefore the answer is going to be same, f of x e raised to x upon a minus f dash of x e raised to x upon a square plus f double dash of x upon a cube e raised to ax minus f triple dash of x upon a fourth e raised to ax plus dot dot dot. This is going to be the answer. And because the first function in E56 is x raised to 3, first term has x raised to 3, second term has x raised to 2, third term has x raised to 1, and fourth term has x raised to 0. And after that, the derivatives are going to be 0, and therefore the answer is of 4 terms. But in general, this is going to be the answer. Is that clear? Very simple. Next problem. E57. Integral x e raised to x upon x plus 1 bracket square dx is okay. Spend some time. Now, as far as this problem is concerned, first function is x upon x plus 1 square, and second function is e raised to x. Therefore, integration by parts will give us e raised to x into integral of, first function is x upon x plus 1 bracket square, and second function is e raised to x. So, x upon u into integral of v minus integral of v into derivative of u. Now, what is the derivative of x upon x plus 1 square? Barabar? Whatever. I mean, this is one way of going about it, but let me show you one more method of this kind of problem where wherever you have e raised to x, you have a support for integration, and that is integration by parts, and you should look out for some standard things. Therefore, let us do something which is standard. Integral e raised to x f dash of x is equal to u into integral of v, that is f u. Suppose you consider e raised to x as u because you have derivative of f of x here. If you consider u as e raised to x and f dash of x as v, see here, that is why LIATE is a thumb rule and it is not theorem, because sometimes you have to be flexible. Here e raised to x is u and f dash of x is v, then the first term of integral will be e raised to x f of x, right, minus integral f of x, integral of v into derivative of u dx. Okay, and then you rearrange this, then you get integral of e raised to x inside bracket f of x plus f dash of x dx. This term taken to LHS, e raised to x is common, f of x plus f dash of x dx seems to be e raised to x f of x plus c, right? So instead of applying integration by part here itself in the first place, what we can do is we can write it as integral e raised to x and then second function as x plus 1 minus 1 upon x plus 1 bracket square dx. This is the same problem I have written it in different way. And now if we split these two, you get integral e raised to x inside bracket 1 upon x plus 1 minus 1 upon x plus 1 bracket square. Now if you observe that if this is differentiated, you get this. So if this is f of x, this is f dash of x. If this is f of x, this is f dash of x, and therefore applying this formula, the answer for the given problem is e raised to x f of x, which is e raised to x upon x plus 1 plus. Understood? Here, what is the trick? E raised to x is u and f dash of x is v. That gives us this formula. But then, with experience only, you will be able to see this. Otherwise, you will have to go for the standard mechanism of doing it. And maybe it becomes complicated here because derivative of this, you have to be extremely good in algebra. Dealing with it, finally you will get this answer. I'm not sure whether those who have found out the answer is using this method or some otherwise, but this is the correct answer. Okay. Let us see if we have some similar problems for this E58. Integral x sin x cos x dx. Correct. Answer for this problem is minus x cos 2x by 4 plus 1 by 8 sin 2x plus c. Okay. Let me give you another problem, but my numbering will collapse anyway. It's okay. E59. Integral e raised to x cube plus x plus 1 divided by 1 plus x square raised to 3 by 2 dx. This problem is of earlier type where your algebraic expression is supported by f of x followed by f dash of x. So it is given that if you split this algebraic term as x inside bracket 1 plus x square plus 1 divided by 1 plus x square raised to 3 by 2, then we have 1 getting cancelled. Therefore, integral e raised to x inside bracket x upon radical 1 plus x square, that is your first term, plus 1 upon what? 1 plus x square raised to 3 by. What is the derivative of this? You try to find out derivative of that. So basically it is x upon 1 plus x square raised to half. Correct? What is the derivative of that? U upon v. So v into derivative of u, which is 1 plus x square raised to half into derivative of u minus u into derivative of v, which is half 1 plus x square raised to minus 1 half whole divided by 1 plus x square raised to 1 half bracket square. Is that right? So what do you get? Do you really get eventually this term? That is the question. So it is 1 plus x square root 1 plus x square plus x upon 2 root 1 plus x square upon
तर तिथे -x/2 कसं काय आलं? तर न्यूमरेटर मध्ये -x/2 कसं आलं?
थांबा बघतो जरा. v into integration of u minus u into sorry v into derivative of u minus u into derivative of v half. तो मायनस हाफ येणार ना. हा जो हाफ आहे तो आला खाली हा इंटू 2x राहिला. हा आता बरोबर. डेरिव्हेटिव्ह ऑफ इनसाइड ब्रॅकेट 2x त्यामुळे तो 2 गेला आणि x स्क्वेअर इथे आला. अरे बरोबर चाललंय का माझं? कोणीच काय बोलत नाही. जाऊ
करेक्ट आहे सर.
बहुतेक बरोबर असेल. is equal to, so this is radical 1 plus x square minus x square upon radical 1 plus x square whole divided by 1 plus x square. And therefore, if you clear this denominator, you get 1 plus x square minus x square upon 1 x square raised to 3 by 2. So x square is cancelled. This is f dash of x. This is f of x. This is f dash of x. And therefore the answer for integral is e raised to x into x divided by radical 1 plus x square by formula that we have proved just now. Here by this formula. Any questions? ठीक है, चांगली गोष्ट है. नेक्स्ट प्रॉब्लेम E59 झाला. E60 अरे काय झालं? E60 is integral x log x square dx. Answer is x square by 2 log x square minus x square by 2 log x plus x square by 4 plus c. E61. If anybody wants explanation, I can write down the complete solution, but I think it is not required. Integral x tan inverse x bracket square dx. Okay, answer for this problem as it is written in my notes is like this. While checking, I checked this term. If it was there, I said it correct. But let me try to solve this. Of course, inverse trigonometric function is there. So LIATE. So I am supposed to consider inverse trigonometric function as u and as v, in spite of the fact that I know that x square is going to grow, but I don't have any choice. Therefore, tan inverse u into integral of v minus integral of v into derivative of u, which is 2 tan inverse x into 1 upon 1 plus x square dx. Right? So this 2 gets cancelled, and therefore the second term is integral x square upon 1 plus x square and inverse x. Now again LIATE, so it is inverse trigonometric function, so I am supposed to consider this as first and integral of this as second. So minus inside bracket, it is better to find out what is the integral of x square upon 1 plus x square plus 1 minus 1 dx. So integral of x square plus 1 is integral of minus integral of 1 upon 1 plus square dx. Is that right? अरे होगा नहीं. What is the integral of this second part? What is this integral? X bracket square upon 2. If we differentiate tan inverse x bracket square upon 2, I think this along with this tan inverse is easily integrable. Therefore, okay. So use integration by parts. एवढे लोग बाहर का पढ़ता है. Integration by parts. Tan inverse x into integral of x square by 1 plus x square is integral of this is x minus integral of 1 upon 1 plus x square dx. नाही काय चाललंय बरोबर चाललंय. Okay. U into integral of v minus integral of v काय चाललंय माझं बरोबर आहे.
So that integral 1 upon 1 plus x square dx should be tan inverse x, right?
1 upon 1 plus x square what?
The integral 1 upon 1 plus x square dx
Uh,
should be tan inverse, right? Tan inverse x.
yes. Something wrong written in my notes. Okay, so integral of x square upon 1 plus x square is x minus tan inverse x. So using that, u into integral of v, which is x minus tan inverse x minus integral of x minus tan inverse x, that is integral of v into derivative of u, which is 1 upon 1 plus x square dx. Is that right? So now if we solve this second integral, this integral, we should be done. So the first term is x square by 2 tan inverse x bracket square minus second term is are we missing half somewhere here?
There is a final integral.
Huh?
Sir, there is an integral remaining which will contribute tan inverse x whole square by 2.
No, but this term, these two terms are getting free now, and the coefficients are not matching here. Okay, x
Sir,
x is there. Okay, minus x tan inverse x. Okay, then plus I am getting tan inverse bracket square minus integral of this is still pending. Okay, so minus integral of x upon 1 plus x square dx plus integral of tan inverse x upon 1 plus x square dx. Now I am comfortable. Okay, so this is same x square. Up to this point it is over. What is the derivative of this? Half log, this is minus half 1 plus x square. And what is derivative of this? It is tan inverse x, and this is derivative of tan inverse x. Okay, so dt, so t square by 2 tan inverse x bracket square by 2. And sign wise is this correct? Minus minus plus. This should have been minus. Okay, I think we are done now. And therefore, the final answer is x square by 2 tan inverse x bracket square minus x tan inverse x. This and this combined together is minus plus half tan inverse x bracket square minus half log 1 plus x square plus. If you differentiate this, huh?
तर साईन्स उलट्या असल्या पाहिजेत ना इंटिग्रलच्या.
What is it?
In the
X
last two
upon
terms,
1
the
plus x square.
sign should be swapped. Last two terms.
This one and this one?
Yes, sir.
No, sir. In the above step, the last two terms.
In the above step, it is minus x upon 1 plus x square.
Sir, somehow those two signs have gone wrong. The last two integrals.
Oh, because there is minus here. Correct. Because there is minus here, this has to be plus and this has to be minus. This has to be plus, this has to be minus. But then what about this?
So that is plus.
That is plus and this is minus. Everywhere I made a mistake, therefore I was consistent, and hence overall there was a mistake. This should be minus, this should be plus. This is the correct answer. Okay. Whoosh. E62. Integral e raised to x square x raised to 3 dx. Okay, this is relatively easy. Solve it. The answer for E62 is x square e raised to x square upon 2 minus e raised to x square upon 2 plus c. Easy. E63. Simple. Integral e raised to sin x sin 2x dx is equal to. Okay, answer for this is 2 sin x e raised to sin x minus 2 e raised to sin x plus c. E64. Integral sin inverse x dx. Correct. Okay. So the answer for this is integration by parts. Second function to be assumed as 1. So x sin inverse x minus integral x radical 1 minus x square dx. So x sin inverse x minus plus radical 1 minus x square plus. That is the answer. E65. Integral sin x log cos x dx. This is easy. Okay, answer for x log cos x dx is minus cos x log cos x plus c. Next problem is integral sine inverse root x upon root x dx. Okay, answer for this, the substitution is root x is equal to t. If you substitute this, you get the integral as integral sine inverse t dt, which is 2 root x sine inverse root x plus 2 root 1 minus x. Is that right? Plus c. E67. Integral sine root x dx. Find out. Okay. Put root x is equal to t, you will get your question converted into standard problem to be solved using integration by parts. The answer is 2 sine root x minus 2 root x cos root x plus c. Next, E68. Integral x minus 1 bracket square tan inverse x minus 1 upon x square minus 2x plus 2 dx. Try your level best. Now here the substitution is tan inverse x minus 1 is equal to t. Let me solve this. Put first of all, this implies x minus 1 is equal to tan t. And the derivative of this is 1 upon 1 plus x minus 1 square, that is x square minus 2x plus 1 dx is equal to dt. And therefore, this is what is your dt. This is what is your t, and this is what is your t square. Therefore, integral converts to t tan t square dt, and hence we are supposed to apply integration by parts. I did not have to write down all the steps. Let me write down the answer. X minus 1 tan inverse x minus 1 minus tan inverse x minus 1 upon bracket square upon 2 minus half log denominator x square minus 2x plus 2. Is this correct? This is what is your answer. Couple of more problems and we are done with integration by parts. Okay. E69. Integral x upon 1 plus cos x dx. Okay, answer seems to be x tan x by 2 plus 2 log cos x by 2 plus 1 plus cos.
सर
हाँ
एकदा कसं करायचं दाखवू शकता का?
हो तेच करतोय. 1 plus cos x is 2 cos square x by 2 dx is equal to हा x by 2 आहे आणि हा sec square x by 2 आहे बरोबर. इंटिग्रल 1 upon x 1 upon 2 x sec square x by 2 dx बरोबर. आता काय करूया integration by parts, which will be equal to 1/2 inside bracket x tan x by 2 into 2, correct. Current sec x by 2 is second function, the integral is tan x by 2 into 2, I mean divided by half on the into 2 minus integral 2 tan x by 2 dx. Derivative of x is 1. This becomes 2 to cancel x tan x by 2 minus हा आतमध्ये आहे ना बाहेर आहे. Integral tan x by 2 is much आगे आतमध्ये x tan x by 2 plus 2 log cos x by 2 plus. Okay, last problem of the day, E70. Integral tan inverse root of 1 minus x upon 1 plus x dx is equal to. अरे सांगा मला.
Sir, x equal to cos 2 theta.
Cos 2 theta. Okay, so you get it in terms of theta. Put x is equal to cos 2 theta. Therefore, dx is equal to minus sine 2 sine 2 theta d theta. So, what is this? Integral tan inverse radical 1 minus cos 2 theta upon 1 plus cos 2 theta into minus 2 sin 2 theta d theta is equal to. This is tan theta, so integral tan inverse tan theta, tan inverse of tan. Presently, I think we should assume it to be theta, d theta. अरे नहीं काय झालंय is equal to integral हाँ करेक्ट है ना minus 2 theta sin 2 theta. Is that correct?
Yes, sir.
And then therefore if you solve this by, I think we have solved this integration by parts, so answer is half x cos inverse x minus root 1 minus x square plus c. Okay, so integration by parts seems to be a very powerful tool for dealing with integrals, provided you have a function which is easily integrable amongst the two. So it is an additional tool because we require many tools to solve indefinite integral, and this is one of the very important. And I have shown you today variety of problems where you should use integration by parts. Now, see, in a particular sequence we are learning, and therefore it is easy to identify what tool to use because we have just discussed that tool before solving these problems. But when it comes to you solving any general problem randomly, it has to be, I mean, all the tools that we have learned should be scanned one after the other, and then you will apply a correct tool for solving correct indefinite integral. That is what is an art which you should develop, skill which you should develop by solving many problems. But presently, today I think we have solved all the problems using integration by parts, but you guys are doing good. I mean, it is not that easy to adjust the terms, algebraic simplification, trigonometric substitutions. You need to be really good in doing that, and majority of you guys have done it well. Okay, so that is where I'm going to stop for the day, and we will look at some special integrals, evaluation of special integrals in tomorrow's lecture. Okay, stop recording.